In this video, I'm going to talk about logistic regression model. In the previous video, we learned linear probability model. In an estimated linear probability model, P hat, or the predicted probability of success, is equal to Y hat, which is equal to beta 0 plus beta 1 x. And the influence of x on P hat is captured by the slope coefficient beta 1, which is constant. And we know that there are some values of x, P hat is greater than 1, and there are some values of x, P hat is less than 0. Therefore, predicted probability can be outside of the 0-1 interval. For meaningful analysis, we would like a nonlinear specification that constrains the predicted probability between 0 and 1. Now consider the logistic regression. Logistic regression, the predicted probability is calculated by this function. I know this function seems like scary, but basically it says that the predicted probability is calculated as e to the power beta 0 plus beta 1x divided by 1 plus e to the power beta 0 plus beta 1x. And if you recall from your college algebra course, e is close to 2.718. The logistic specification ensures that estimated probability, this P hat, is between 0 and 1 interval. The logistic regression model cannot be estimated with standard linear regression procedures. Instead, we rely on maximum likelihood estimation. In this video, I'm not going to explain you the theoretical aspect of maximum likelihood estimation. Our focus is the interpretation and application of this model in business problems. One important point here is that maximum likelihood estimation is not supported by Excel, but it can easily be estimated with most statistical packages including Analytic Solver and R. Now check this figure here. The linear line represents linear probability model and the green line shows logistic regression. Linear probability model predicts probabilities on a linear line, and logistic regression predicts probabilities on a nonlinear line, looks like letter S. And for linear probability model, for large values of x, the model can predict probabilities greater than 1. And for small x, the model can predict probabilities less than 0. So we have 2 points here. Linear probability model. Probabilities can be greater than 1 or probabilities can be less than 0. In logistic regression, probabilities are always between 0 and 1 interval. But note that here is very important. The coefficients and their estimates have a different meaning depending on which model we are referring to. Next, we are going to focus on interpretation of the coefficients, both in a linear probability model and logistic regression model. In a linear probability model, the interpretation of regression coefficient is straightforward. For instance, if the estimated probability model is P hat is equal to negative 0.2 plus 0.03x, it implies that for 1 unit increase in x, the predicted probability increases by 0.03. And note that predicted probability increases 0.03 whether x increases from 10 to 11 or x increases from 20 to 21. Now let's consider the logistic model. And let's assume that the intercept from the logistic model is negative 2.10 and the slope coefficient is 0.18. So if we want to predict the probability, we will use logistic specification and we are going to write here e to the power minus 2.1 plus 0.18x divided by 1 plus e to the power minus 2.1 plus 0.18x. Because the regression coefficient beta 1 is 0.18 is positive, we can infer that x has a positive influence on p hat. However, the exact impact based on the estimated regression coefficient is not obvious. A useful method to interpret the estimated coefficient is to highlight the changing impact of x on p-hat. For instance, if x is equal to 10, we can calculate p-hat. How are we going to calculate p-hat? We are going to plug here instead of x 10 and here 10 and find the value for p-hat. And if we do this calculation, you are going to find that p-hat is 0.4256. And when x is equal to 11, we can do the same thing. Instead of 10 here, we are going to plug 11. And p-hat is going to be 0.4700. So therefore, as x increases by 1 unit from 10 to 11, the predicted probability increases by 0.0444. And as you see, this increase is not equal to the slope coefficient beta 1. And we can also calculate increase in p-hat when x increases from 20 to 21. When x is 20, p-hat is 0.8176. And when x is 21, p-hat is 0.8426. So the increase in p-hat is equal to 0.0253. So let's highlight these two values. And as you see, the increases are not equal. Plus, when x is relatively large, its impact is decreasing on the predicted probability. And this is also consistent with the logistic specification. Let's go check here. When x is large, let's say here, the change in x, the same change in x, will change the probability, let's say here, this much. But when x is here, the same increase in x change the probability this much. So the changes are not equal and the x influence is decreasing when x is large. And now in the next video, we are going to learn how to apply logistic regression once we have the data using analytic solver.